since there's a relationship between the roots, aka radicals, and our normal powers, there's at least that connection that we can establish between polynomials that are on the simpler, streamlined side, and roots. Also, as a quick reminder here, remember that we've got the relationships between roots and fraction exponents. So if we have a fraction exponent, the denominator of that fraction exponent corresponds to the type of root that we have. And if there is a non-1 numerator, it could be something that we put inside of the radical or outside, depending on what might be more useful to us under the circumstances. If our root is even, then we do have a restriction about what we're allowed to plug in. We're only allowed to plug in numbers that are greater than or equal to 0. But for those odd roots, there is no restriction at all. So domain, only got to worry about the even roots. For those even roots, we can take our square root graph and basically just, make an adaptation of it. Notice that's a similar kind of shape, but without any scaling here. I don't see any sort of differences. If I have a specific type of even root, I could then come in and put in specific markings for the x's and the y's and say, okay, what does that shape look like? I can compare it to other kinds of even roots, but basically speaking, they all look like that. Whether we're zoomed in or zoomed out, they all have that same kind of basic shape or look to them. If we have an odd root, we have this sort of snaky S shape that we could be looking at. And again, we've got those different transformations that might pick things up and move them. It might stretch them one way, squish them one way, stretch them one way, squish them one way. But generally speaking, those are the two basic shapes that we've got. We've got our domain issues. And just to touch on those a little bit more, even roots versus odd roots, that's the big deal. Even root, what's in the root has to be greater than or equal to 0. That's going to have an impact on our domain. For odd roots, there is nothing that is an issue about what's inside the root, and that would mean that in this particular case, there's no restriction about what x can be, because, hey, if 7x plus 36 can be anything, well, I can take anything and subtract 36. I can take that and divide by 7. And so, well, shoot, x can be any darn thing I want. And there's no issue whatsoever with doing a 7x plus 36 and then slapping it underneath of an odd root. So odd roots, usually a whole lot nicer for us to address as far as domain. We also have our equation solving skills that come into play as far as needing to find any x-intercepts. We have our simplification skills that might be necessary for any y-intercepts. But one of the things that's really rather handy for us is that if we've got the roots at our disposal, then we can handle a lot of other kinds of graphing that might show up. Like at the moment, we don't have any nice way of trying to take care of graphing what would end up being a circle. We don't have any way of being able to graph horizontal parabolas. The algebra that we're looking at hasn't necessarily been something that directly allows us to handle that. We would have to have some sort of other clever way of addressing that. Well, one of the things that we can do is use radicals. So if we've got an equation like this, x equals -1/4 parentheses y minus 3 parentheses squared plus 1, you go, wait a minute, I don't like that. It's x's and y's aren't set up the right way. Hey, if we solve that for y, we go through watching out for the plus or minus when we do the square root of both sides. We end up getting two separate equations that allow us to put together a complete picture of what is happening. And what we would have, and I challenge you to check this out, if you punch these into your graphing calculator, y number 1, y number 2, let your calculator draw both of those, what you will see within the limitations of your graphing calculator is that you have a sideways parabola. So we've got options for a little bit more variation, a little bit more flexibility of what we can do, being aware of those kinds of relationships. We'll also come around to seeing how the relationship between radicals and powers ends up being even more useful to us in another little bit.